In this video, we will be looking at standard form of an equation. By the end of this lesson, you should be able to graph linear equations in standard form by finding x and y intercepts. So let's talk about what some of these words mean. A linear equation is an equation whose graph is a line. So any equation that forms a line is a linear equation. Standard form of a linear equation is a specific type, and we write it in the form ax plus by equals c, where a, b, and c are real numbers, and a and b are both not zero. So we want to keep in mind that ax plus by equals c is our standard form. When we see an equation in this format, we notice it's in standard form. So we can graph a linear equation in standard form by finding x and y intercepts. So let's review x and y intercepts. Recall that an x-intercept, or a zero, is where the graph crosses or touches the x-axis. And at the x-intercept, remember that y is equal to 0. My y-intercept is similar. My y-intercept is where the graph crosses or touches the y-axis. And at the y-intercept, x is equal to 0. That's going to be important as we move forward in solving our equations. So let's take a look at some examples. Graph each of the following linear equations. So I see an equation written 5x plus 2y equals 10. I know this is in standard form because I see 5 is my A, 2 is in the B spot, and 10 is my C. So I want to graph them by using my x and y intercepts. So I'm going to look at my x-intercept first. My x-intercept, at my x-intercept, I remember at my x-intercept, y is equal to 0. So when I find the x-intercept, I'm going to write my equation 5x plus 2, and then instead of writing y, I'm going to write 0 equals 10. Because y is equal to 0, I'm going to use my substitution property and put 0 in for y here. Okay. And then 2 times 0 is 0, so that will cancel out. That's the same as 5x plus 0 is equal to 10. And 5x plus 0, my identity property is 5x is equal to 10. I want to divide both sides by 5 to solve for x, and x is equal to 10 divided by 5, which is 2. This means that the x-intercept is the point 2, 0. So I'm going to come over to my graph and plot the point 2, 0. Now I want to take a look at my y-intercept. So it's the opposite. At the x-intercept, y is 0. At the y-intercept, x is equal to 0. So I'm going to follow a similar path, but now this time I'm going to write 5, and instead of writing x, I'm going to write 0 plus 2y is equal to 10. So now the same thing will happen. 5 times 0, it will cancel because 5 times 0 is 0, plus 2y is equal to 10. 0 plus 2y gives me 2y is equal to 10. And lastly, I'm going to divide both sides by 2. Y is equal to 10 divided by 2, which is 5. So the y-intercept is the point 0, 5. So just like I graphed 2, 0 over here, I'm going to graph 0, 5, 1, 2, 3, 4, 5. And then I'm going to draw my line connecting those 2 points. That is the equation. I've just graphed this equation using the standard form and using the x and y intercepts. We have a few more special examples. So in this example, I have y equals 4. So notice when I do have y equals 4, there's no x. This is the only number that's there. This is a special type. We'll look at two of these. For one like this, when you just see one letter equals a number, it's going to be either a horizontal or a vertical line. So when we see a y equals, we know that this is actually going to be a horizontal line because we know with y equals, we have a horizontal line. We also know for a horizontal line, it has 0 slope. And the equation is going to look like y equals a number. In this example, y equals 4. So we use this acronym HOI. You can write it out just like this. We use that acronym to help us remember which one is which. So y equals 4 line, that means that I come over to my graph and I go up 1, 2, 3, 4 to y equals 4. I can put a point right there. And I know it is a horizontal line. Remember, a horizontal line is one that looks like this. So I know I'm going to put a horizontal line right through that point. And this line, the line that we just graphed, it has 0 slope and it's a y equals line. But notice that there's no other variables. In my other one, I had a y, but I also had an x. This one only has a y. Similarly, if you flip your paper over, if we have an x equals line, this one says x equals 1. It's a similar idea. We have x equals a number. Instead of a horizontal line, this is going to be a vertical line. And the kind of slope it will have is undefined. So when I graph this, I'm going to go over to x equals 1, which is right here. And I am going to draw a vertical line through that point. So my vertical line goes up and down. The acronym that we use for this is VUX, V-U-X. So you can write it just like this, VUX, so that you can remember that VUX is an x equals line and HOI is a y equals line. And notice here too, there's no other variables. I don't have a y, I only have an x. That's what makes this special case. So you can use this VUX acronym to help you remember.